This is the calculation side of the Hydrate lab. You've already obtained the data necessary for the calculations. It includes sort of three things. The weight of your hydrate solid, so you had made it either fast or this is for the slow growth crystals. And remember, it has 2 sodium ions for every 1 sulfate as a ratio in the crystal. Doesn't mean you have again, just 2 sodium ions and a sulfate. It's just within this crystal, and we said there's some water now present that we're trying to define. We're trying to define how much of the water do we have per 1 mole of the sodium sulfate. So it's called a hydrate formula, where we have Na2SO4, and we have a dot there telling us how much water we have within this type of hydrate. That's what we're looking for, is this how much water in moles for every 1 mole of sodium sulfate. So the weight of the hydrate, you'll put, I guess, as an entry into your calculations at the very top. Just want to leave it there, and it's in grams. And then you'll have the weight of your dried hydrate. So of course this weight will be more than number 2's weight. Why? Because you've removed, when you heated this crystal in the oven for 20 minutes, it's driven all the water away. So once you have that weight, so if you don't mind, you're going to again use your numbers. Let's say we had 1 point, just hypothetically, I'm not saying hypothetically, let's say you had 1.25 grams of solid left. You're going to need to convert that to moles. Convert this to moles. So take that weight of dried hydrate and know how many moles you have of sodium sulfate. So to do that, you're going to divide this, because for every 1 mole, you're going to divide it by 142. Sorry, didn't finish what I was going to say. 0.04 grams. Because 1 mole of Na2SO4 weighs this much. So I just want to check. So you'll may want to check that. 142.04 grams is what I have as the molar mass of sodium sulfate. You say, well, why am I doing that? So that I can cancel the units, and this would now give me the moles of Na2SO4. And this mole value, now you're going to take and use later on in the calculation. We're almost done. What's the next number I need for the calculation that's critical to find this question mark? I need water, the weight of water. Well, we know, we said between 1 and 2, all the water was driven off. So we can take the weight of 1, subtract the weight of 2, which is just the sodium sulfate, that's all that's left. That would be the amount of water driven off. So number 1's weight minus number 2's weight, and then you're going to convert that to moles using the same sort of calculation, but you're of course going to use division by 18 grams, because every 1 mole of water. So you're going to have your weight of your water, and you're going to have to just divide by that 18 grams, because 1 mole of water is equal to 18 grams, and that'll give you your moles of water. So now we'll have moles of water, and we'll have moles of our sodium sulfate. You'll need to divide the moles of water in number 3, divided by the moles of sodium sulfate that you calculated from 2's weight, and that'll give you, again, the number we need. That number that you'll be able to put into, in your book, you'll need to finish with your calculations having all of this. Of course, your numbers underneath this heading, hydrate of sodium sulfate under calculation. You need to show all this work, but of course put your numbers in. What did I get for moles of water? What did I get for moles of sodium sulfate? Divide the moles of water by the moles of sodium sulfate, and that'll be the number we need, that, number of water molecules per every 1 mole of sodium sulfate. Thanks. Bye-bye.